I thought I'd do a video on the 18F series microcontrollers by Microchip. If you're familiar with the 12F and the 16F series, the programming is a little different with this one. And if you've ever bought one of these, sometimes it can be very confusing just to get your first program working. So in this video, I'll just show you how to get the most basic program working, which is what they call kind of a hello world, or just a blinky light, or my first project type of a program. And it's just from one end to the other. It'll be a quick program, a quick project, turning on and off this light maybe once every second, and using this microcontroller right here. So let's kind of get the whole thing going here. First, I'll show you the project. It's going to be just a very simple project, obviously. This will be an unedited video because it takes so much time to edit these things. And so this is a PIC 18F 46Q10, and it happens to have I think pin 11 here is your power, and I'm going to put two AA batteries on here for the power source, and on pin 12 I'm going to put on the ground side of the batteries. And I'm going to have that little light, or LED, blinking at, I'll plug it into pin 2, which happens to be the port A bit 0. So that's what I'm going to be turning off and on to make this LED work. I think that's my whole schematic right there. Okay, so anyhow, as you can see, my PIC 3 programmer is right here, and it's plugged into my computer through a USB port. And I'm just going to drop this chip here, this microcontroller that I have, in here, and it will be programmed from there, and then we'll put it together after I program it. Yeah, so let's go over and do some work on my desktop here. Okay, so this is the free download I got from Microchip, and it's called MPLAB XIDE. That little blue one right here, that is. It's actually version 5.20, and I'm using assembly language to do this quick program. And this is the only tool I use to do all my programming. So it does the compiling and the programming and everything inside here. So that's the start page. We'll just get rid of that. And we have a blank slate here. So the first thing we want to do is start a new project. So click on File and click on New Project. Run over here, and it's going to be a standalone project. Click Next. And what was that called? That was a 18F 46Q10, I think. Yeah, there you go. Let's use some cap locks here. Okay, next. And I'm using my PIC Kit 3 programmer. Click Next. And I'm using the compiler that came along with the download, the free download, by the way. We're going to call this Q10, oh, I don't know, maybe 7. Not much of an imagination. That's my project name. Just Q10 is the last 3 letters and numbers of the chip or microcontroller we're using here. So I'm going to put my file into the source files here. So I right clicked and left clicked on that there, and I'm going to add an assembly file as I'm going to call it Q10 7. Oops. Like this. Like that. Okay, so that's my file name inside my source code there. Okay, so at this point, you do have to configure your chip. And what you do is go to Production and Set Configuration Bits. And here we're just going to configure the way we want the chip to run. And this is necessary, or else the chip will not know whether to start up with an external oscillator or an internal oscillator. And I'm going to say I don't want an external oscillator, but I do want an internal one. I'm going to use an internal low power one, a low frequency internal oscillator. And that's good. I'm gonna not use any of the features. I'm gonna turn everything off I can find. Master clear bit will be internal. What else do we have here? Go all the way down, brownout. I'm going to turn that off. And I'll also turn everything off in sight. Except I do have something I want to do. I'm going to use the watchdog timer. So I've already figured out what I want for the settings, and I'm going to set it for the same frequency as the main processor, which is the low frequency internal oscillator. What else here? I think I'll turn off this right here, turn off this right here, and that's it. That's all my configuration bits I want to change. I'm going to generate the source code from that. I click here and it generates some source code, and I'll paste this into the top of my program here. So I cut and paste it. Oh, I'll copy and paste anyhow. And let's put it right on the top of my program here. It's a big, huge header. And as you can see, there it is all right there. So we go to the very bottom and we start to program right there. So I'm just going to type out how much tabbing. Well, maybe not that much tabbing. About there, I think. I'm going to type out one directive here, telling the compiler where I want the origin of the code to be, and it's going to be at address 00, and then I'll start my program here. This is where the program actually starts. I'm just going to put something into an address into the banking register here, and I'm going to clear a file register. Oh, okay, the analog select bit here. Yeah, so this is going to just turn all of port A into a digital port so I can use it. And then I'm going to make it all output. That's what that just did. So actually I want to go and put a label right here. That's a label because I'm going to be coming back to that spot in a bit. So I'm going to turn on the LED right here, port A, bit 0. So bit set file register port A, bit 0. That's what that did. Now maybe I will put the processor into sleep for about a second. And the reason why it went to sleep for about a second is because that watchdog timer, I programmed it way at the very beginning to time out in 1 second. Then when it wakes up, first thing that will happen is my light or LED, I guess it's a LED, will turn off. Bit clear file register port A, bit 0. And then I'll put that processor back to sleep for another second, and then I will go back to the loop and do this until the batteries run out. You always need an end statement, so that's what that is right there. So that's the length of the program. It's about 8 lines of code, or 8 instructions, very small. And let's compile it. I'm going to go over to Hammer here and hit the hammer and see if it compiles cleanly. Yes, it did. It says build successful. Now, what I want to do is I want to, before I put it into my PIC Kit 3 or the code into my my chip, I want to change my PIC Kit 3 so that it will receive 5 volts of power from the USB port. So I've just requested to have 5 volts sent to my PIC Kit 3, so now it can program my chip, and then I will program it now. Okay, so it's taking the program we wrote and and put it into that microcontroller sitting on the breadboard. That's just to do with low power programming. That's not really important, but Let's see how it does here. It says configure, programming, verify, complete. Oh, that's fantastic. That's great. Then now we have what we got here. I'll just pull that chip out of there and I'll put it into the breadboard over here where, if you notice, I have right here 2 AA batteries plugged in there. So let's remove it with my fancy IC removal tool. We might call this a steak knife, but it's what it is today. Now, where's that little LED? So this LED, I think I said I wanted it to go to pin 2. Is that right? I believe it was. So yeah, there you go. So yeah, that was port A, bit 0 right there, and it's just going to ground right there. So that's the whole project. Pretty straightforward. Hopefully you guys got something out of this, and thank you for watching.